Ladies and gentlemen, let us see something under the base and the derived quantities in physics. It's one of the foundational topics that you are going to learn, and it's quite important because understanding units helps you to put the correct units for each quantity that you are trying to measure. Now, we have this base where we have what we call the base units, all right, or you can call them the base quantities. All right, let me call them the base quantities. These base quantities, they are quantities that occur or that happen to be without any combination. All right, they occur on their own. All right, so these are what units without, or let me say they are quantities. All right, without any combination. All right, with any unit. Let me see, with any quantity, for example. Even here, let me put quantity. So they occur on their own. They are never combined with anything else. While, on the other hand, we have a derived units. Which are units, or let me say quantities. Let's use quantity for. These are quantities, all right? Which are as a combination, which are what? As a combination of what? Base quantities. Now from here, that's where we get what we call the base units and the derived units. All right, because a base unit, sorry, a base quantity, it should have a base unit, and a derived quantity, it should have a derived what? Unity. All right. Now, for example, examples of base unit, we have 7 of them. Take note, there are 7 base units, or let me say base quantities. Well, these ones, they are quite a lot, uncountable. All right, they are what? Uncountable, because they are quite a lot. And we are going to, for example, you can get distance or length, you combine with what? Time, the one you call meter per second, which is velocity. Velocity is a derived quantity. Or you can say Newton per meter is also a derived unit. All right. Or you can say meter per second squared, which is the common unit for acceleration, which we know it is. All right. Or we can say a force is a kg. All right. Meter per second squared. This is a force. So all these are examples of derived unities. Now, let's complete this table by fixing in the base quantity, the SI unity, and its symbol. So let's just start with length. Length is a base quantity. Its SI unity is meter, and the symbol for meter is small letter m. Don't write capital letter M, it will mean something else. The next is time. Time is a base quantity and the SI unit is second. Small letter s, not capital letter S. The next base quantity is mass. And the SI unit for mass is kilogram. A kilogram. This is the SI unit for mass and it's kg. It's making sense, right? Good. The next one is temperature. Temperature. The SI unit for temperature is Kelvin. And should start with the capital letter K because it was named after the Kelvin scientist. So this is just a letter K, capital letter K. We have current, which we know the electric current. The SI unit for an electric current is an ampere. Alright, which is abbreviated as capital letter A. Capital letter A. Next is the luminous intensity. Luminous intensity. Start with some light and so on. It's candela, which is capital C, then D, CD, candela. Then the other one is amount of substance. The last one but not the least is amount of what? Substance. Amount of substance. The SI unit for amount of substance, alright, is what we call the mole. Small letter O, M, and then O, which is symbolized as MOL. These are the 7, alright, commonly used base units, which I want you to know by heart. In case they ask you, you should be able to list them, write their SI units and their symbols. Alright, so I hope you really enjoy this video. Online classes, they are available. Let us know how it can help you. It's quite affordable. You can learn and pass. Whether you have a busy schedule or not, our classes, they tackle for everyone. And you're also welcome. Mathematics are available, science is available, biology is available, English language is also available. Do not hesitate. We can help you. We've done this before.